Hello everybody and welcome to another Houdini tutorial. My name is Kate and today we're going to be talking about three nodes which control visualizing the residues and nucleotides of proteins. Now, it's really quite simple. The first thing you need to do is bring in your protein information and translate it to the center of your scene or wherever you'd like. The next thing to point out here is that each of these nodes has two inputs. Two outputs, my bad. One outputs the model, and the other is output the points, in case you wanted to do something with them later. So let's talk about deoxyribonucleotides. So heads up, I can't pronounce either of these names correctly. I'm going to butcher them, but I'm going to walk you through these nodes. So you might notice this particular one isolates all the different types of types of nucleotides that this one covers, and it also isolates water. So if you wanted to see all the water molecules in the structure, you could do that as well. You can make them active, which basically adds an active group onto these particles if you wanted to use them in calculations. You can also switch to space filling, which doesn't really work with residues, as I find they're just represented as particles that are not really connected to each other in 3D space, but those options are there for you if you need them. You can also play with the voxel size and the space filling size and the point radius scale. You can also, down here, play with all the visualizers and the total count of the atoms like this. We'll leave atom count on. Now, the other thing you might notice up here is that there's search points and search radius and connections. So the connections shelf we wouldn't really need for something like this, but if these molecules are closer together and actually, connecting with each other, maybe we'd want to make connections between them like this. But instead that looks kind of weird, so we can just keep them off for now. You can also control the wire radius of these connection points and the connection color. This is where you can turn on the base color for the elements and the atomic size. So this is where you can play with the atomic size of the atoms that are in this. If we go to the geometry spreadsheets, you might notice that all of these have O's in them, and that's because these are all oxygen atoms that exist in water. Unfortunately, as I've kind of pointed out in another tutorial, because PDB uses crystallography a lot to do protein scans, it unfortunately doesn't map hydrogen atoms successfully. So as of right now, we don't have a way of visualizing the hydrogen in 3D space, so that would probably be another HDA that I would need to design and add into the toolkit to kind of guesstimate where these hydrogen atoms would be. But yeah, that's pretty much it for this side, and I think that's much it for this node. So if we go to the residue isolator, it looks very familiar. The only thing it does is isolate different residues. So once again, you can scale your atoms and add customized scaling to them. You can also use something called switch isolates to isolate different kind of residues in the structure. And you can visualize the different elements if you want to. This might not work because we only have these colors set up for these kind of elements, so these might be a different element overall, so let's check. This is currently deleting the element information, so that would probably need to be updated once we get around to, improving these tools. But once again, you have options for turning off the total count. If we go over here to the ribonucleotide, this is where you can see, once again, it's isolating, allows you to isolate other residues. And also count their atoms as well. You can, once again, isolate certain different nucleotides by, guesstimating their number. 61 might be too much, but like that, you can isolate them. You can also do switch to space filling, which will create these little circles in 3D space. And you can also make them active if you wanted to use them later. You can also play with the voxel size and the point radius scale, so you can make them bigger or smaller if you wanted to. Space filling size, so if you were to switch to space filling, this is where you can make the space filling bigger. Now if we go down to connections, this is where you can play with the wire radius. And you can also play with the search radius if these connections don't look realistic to you. Atomic size is where you can play with the atom size if you wanted to. And the element visualization if you wanted to visualize the elements in the nucleotide. So that's pretty much it. And I hope you enjoyed this tutorial. My name is Kate, and I will see you in the next video. Bye.